Hi everyone, welcome to Tech Mastery Guru, where we decode technology, careers, and strategy to help you stand out. Today we will explore Internet of Things and AIoT, future trends, skills, and careers. This video will provide a comprehensive exploration of the IoT and AIoT landscape. Our agenda covers 5 key areas. First, fundamentals and evolution of IoT. Second, its architecture and ecosystem. Third, technologies and trends, including AIoT synergy. Fourth, use cases and applications. And finally, we'll discuss skills, careers, and engagement in the IoT/AIoT space. IoT truly matters in 2025. We anticipate 18.8 billion connected devices by the end of 2024, with the market size reaching $1 trillion by 2026. Asia-Pacific alone is projected to spend $241 billion on IoT by 2025, driven by smart homes, industrial modernization, and power grid digitalization. The IoT vision is about connecting everything. It merges the physical and digital, enabling seamless connections between people, processes, data, and things. Environments learn and adapt, making autonomous decisions and creating new value from data. This integration makes our world more responsive, efficient, and capable. There's significant motivation for pursuing an IoT career. Professionals command 15 to 40% salary premiums, with demand growing 5 times faster than supply. IoT skills are cross-industry relevant, offering flexibility. Plus, you can make a meaningful impact on sustainability, safety, and quality of life. So what exactly is IoT? It's a vast network of interconnected things with unique identifiers. These devices have sensing capabilities, processing power, and communication features. They also possess actuation, enabling them to influence the physical world. This network allows for automatic, data-driven decisions in real time. The IoT timeline shows rapid evolution. In 1999, Kevin Ashton coined the term Internet of Things. The 2000s saw early adoption of RFID and M2M communication. The 2010s brought consumer IoT and smart homes. Now, the 2020s focus on edge computing, 5G, AIoT, and digital twins, making IoT accessible to more sectors. IoT can be broadly categorized into consumer and enterprise/industrial IoT. Consumer IoT focuses on convenience and lifestyle, seen in smart TVs and wearables. Enterprise IoT prioritizes operational efficiency and data insights, like factory automation. These domains are now converging, blending security with user-friendly interfaces. Industry 4.0 marks the fourth industrial revolution, merging cyber-physical systems and advanced robotics with IT and operational technology. This brings increased equipment effectiveness, reduced downtime through predictive maintenance, enhanced quality control, and optimized energy consumption. Siemens digital factories exemplify this with exceptional efficiency. Industry 5.0 is the human-centric evolution, emphasizing human-machine collaboration and personalized manufacturing. Key characteristics include resilient systems and ethical technology. It expands KPIs beyond efficiency to include sustainability, worker safety, and social impact, augmenting human capabilities and promoting responsibility. Industrial IoT, or IIoT, focuses on manufacturing, utilities, and infrastructure. It features cyber-physical systems for monitoring and control, real-time communication for critical data exchange, and predictive analytics to prevent failures. Safety and reliability are paramount, with redundant systems ensuring continuous operation. Why invest in IoT/IIoT? The business value is clear. Operational efficiency through optimized resources, deep customer insights, new business models like product as a service, and scalable growth. Studies show organizations leveraging IoT/IIoT report significant cost reductions, productivity improvements, and decreased downtime. IoT architecture consists of 5 layers. Starting from the bottom, the device/embedded layer includes sensors and microcontrollers. Above that is the network layer with various communication technologies. The edge computing layer provides local processing, followed by the cloud/platform layer for data storage and machine learning. Finally, the application layer offers user interfaces and analytics. Embedded software architecture is crucial, balancing resource constraints and power efficiency. Firmware components include real-time operating systems and device drivers. Middleware handles communication stacks, security, and over-the-air updates. This complex interplay ensures robust performance, even in challenging environments. The IoT ecosystem is diverse, involving hardware vendors, connectivity providers, and cloud platforms. Software developers and system integrators build the solutions, while end users benefit. Standards bodies ensure interoperability, creating common frameworks for scalable deployment across this complex network. Understanding IoT protocols and networks is vital. Lightweight protocols like MQTT and COAP are ideal for constrained devices. LPWAN technologies, such as LoRaWAN and nitrogen monoboride IoT, offer long-range, low-power communication. Short-range options include Zigbee and BLE. For high throughput, Wi-Fi 6 and 5G are key. Choosing the right one ensures efficiency and scalability. Several popular IoT kits and embedded boards facilitate development. Arduino boards are excellent for beginners. ESP32 and ESP8266 offer affordable Wi-Fi/Bluetooth. Raspberry Pi is a powerful mini-computer for gateways and edge computing. Node MCU, BeagleBone Black, STM32 Discovery Kits, and Texas Instruments Launchpad also provide diverse options for prototyping and professional applications. Open-source platforms are crucial for IoT innovation. Platform.io provides a unified IDE for various boards. Node-RED offers visual programming for rapid prototyping. ThingSpeak is a MATLAB-based analytics platform. Blink allows for custom mobile app creation. GitHub hosts countless IoT libraries, and OpenHab and Home Assistant offer powerful smart home automation. IoT systems generate vast amounts of data, requiring sophisticated management. The IoT data pipeline involves collection, efficient transport via protocols like MQTT, and storage in time series databases. Processing includes machine learning and anomaly detection, culminating in visualization through dashboards for actionable insights. Edge and cloud processing combine for immediate and deep analysis. IoT security and privacy are critical. Persistent threats include default credentials, weak updates, and exposed services, with Mirai botnet variants still active. Essential controls involve zero-trust architecture, cryptographically signed firmware, and continuous vulnerability management. Behavioral anomaly detection is key to protecting these interconnected environments. The expanding IoT attack surface presents significant security challenges. Threats include device hijacking, man-in-the-middle attacks, ransomware, and data breaches. Essential measures are secure boot, device authentication, end-to-end encryption, and regular updates. Privacy considerations like data minimization and user consent are vital for compliance with regulations like GDPR. AIoT, the fusion of AI and IoT, empowers devices to think, learn, and act autonomously. It transforms passive systems into intelligent ones, enabling intelligent automation, real-time insights for predictive analytics, and advanced personalization. AIoT is rapidly redefining industries, boosting efficiency and safety, and creating demand for specialized skills. The AIoT synergy creates predictive systems that forecast failures, autonomous systems that self-optimize, and cognitive systems that understand context. These adaptive systems learn and improve over time, transforming passive monitoring into proactive solutions that deliver significantly more value than either technology alone. Smart homes are a major IoT application, contributing significantly to consumer IoT revenue. This includes voice assistants as central hubs, intelligent climate control systems, smart lighting with scheduling and customization, and networked home security with AI-powered threat detection and remote access. These innovations enhance convenience and efficiency. IoT is revolutionizing healthcare, with the Internet of Medical Things, IoT market projected for significant growth. It enables remote patient monitoring for chronic disease management, improves hospital efficiency through asset tracking and optimized environmental controls, and aids diagnostics with AI-enhanced imaging analysis, ultimately enhancing patient care. Connected healthcare, or IoT, transforms delivery through continuous monitoring and early intervention. Remote patient monitoring uses wearables to track vital signs. Hospital asset management optimizes resource allocation. Early warning systems detect patient deterioration with AI. Apollo hospitals, for example, significantly reduced code blue emergencies and nurse workload using automated vital sign monitoring. Smart cities leverage urban intelligence across various sectors. Barcelona's smart water systems save millions through leak detection. Smart parking increases revenue, while adaptive LED street lighting adjusts brightness based on activity. Waste management uses fill-level sensors to optimize routes, and smart grids enable demand response and distributed energy integration. Smart agriculture, or precision farming, uses IoT to optimize resources and increase yield sustainably. Soil monitoring sensors guide irrigation and fertilization. Microclimate tracking provides field-specific data. Variable rate irrigation adjusts water delivery based on needs. John Deere's See and Spray technology, for instance, significantly reduces herbicide use through precision spraying. Industrial IoT drives predictive maintenance by capturing equipment vibration and current patterns to identify faults. Algorithms analyze these patterns to detect bearing wear, electrical faults, and insulation breakdown. A wind turbine case study shows machine learning models can predict gearbox failures 7 to 14 days in advance, reducing false alarms and increasing turbine availability. Energy and utilities are undergoing transformation with smart metering. Leading utilities use RF and nitrogen monoboride IoT for real-time demand response and predictive outage analytics. In India, Tata Power DDL, in partnership with Jio, has deployed over 400,000 smart meters in Delhi, showcasing the country's commitment to smart grid solutions. Logistics and cold chain monitoring are being revolutionized by IoT. Devices track GPS, temperature, humidity, shock, tilt, and light to ensure product integrity and optimize routes. The COVID-19 vaccine distribution set new standards for temperature-sensitive logistics, including continuous monitoring and real-time alerts, now foundational for global pharmaceutical and food safety. Retail and connected commerce are evolving with IoT. Proximity beacons offer location-aware shopping. Dynamic pricing adjusts based on demand. Autonomous microstores provide frictionless shopping with automatic checkout, exemplified by Amazon's Just Walkout technology, which combines computer vision, sensor fusion, and RFID for checkout-free experiences. Smart mobility and electric vehicles heavily rely on IoT. Tesla leads with over-the-air diagnostics and updates, continuously improving vehicle performance and features. Connected EVs use real-time data for intelligent route optimization, reducing range anxiety. Smart charging orchestration balances grid demands and optimizes charging based on renewable energy and pricing. Wearables have evolved from consumer gadgets to clinical tools. Health-grade monitoring now includes ECG, blood oxygen, fall detection, and continuous glucose monitoring. Industrial safety innovations use smart PPE for fatigue sensing, hazard detection, and posture monitoring, significantly enhancing workplace safety and emergency response. IoT significantly contributes to sustainability. John Deere's See and Spray technology, for example, achieves up to a 77% reduction in herbicide use and 30% in water conservation through precision agriculture. Smart buildings reduce energy consumption, power grids minimize transmission losses, and fleet management optimizes routes, all contributing to a greener future. IoT/AIoT offers diverse career paths. Core technical skills include embedded systems, networking, cloud services, data analytics, and full-stack development. Career roles range from IoT engineer to solution architect, AIoT analyst, security specialist, and product manager, often commanding significant salary premiums. Learning resources like NPTEL and AWS/Azure certifications are readily available. The IoT sector is experiencing rapid expansion, creating substantial employment opportunities globally and in India. Over 50,000 new IoT job roles are projected in India by 2025, driven by manufacturing, health tech, energy, and logistics. The global IoT engineering services market is forecast to exceed $71 billion by 2027, with demand from tech giants and innovative startups. IoT engineer salaries vary by experience and location. Freshers can expect 3 rupees minus 8 LPA in India, while senior professionals can earn 20 rupees minus 40 LPA. In the US, salaries range from $56,000 for freshers to over $120,000 for experienced engineers. Specialized roles like IoT solutions architects command even higher packages, reflecting high demand for their expertise. In summary, the IoT and AIoT landscape offers dynamic career paths. There's robust market demand, high-value specializations, and diverse industry impact in sectors like manufacturing, health tech, and automotive. These trends highlight a vibrant and evolving career for those passionate about innovation in connected devices and intelligent systems. Leading hardware and embedded companies, including Intel, Texas Instruments, and Qualcomm, are actively seeking skilled IoT engineers. Samsung, Philips, Bosch, and Honeywell are also major players, driving innovation in connected devices across various industries, from silicon design to integrated system development. Thank you for watching. If you found this session useful, hit like, share, and subscribe to Tech Mastery Guru for more technology videos.